Before we jump whole hog into texturing this thing, we need to talk about mapping coordinates, or UVs. UVs, or mapping coordinates, in most 3D applications you would call them UVs. 3D Studio also calls them mapping coordinates. You can call them either one. I'll use that interchangeably. But they're simply a way to have a texture drawn onto a 3D object. So if you have something like it's incredibly easy to visualize with something like a plane. If you have a plane here, this is a 3D object, right? You can move it around, manipulate it. Now if we put a material on that object, look at our material editor here, pick a slot, assign it, and we put a texture map on this thing, a bitmap. I'm going to come down here and I have it's a BMP, so somewhere I have this thing uv.bmp, and this is a little utility map that you can use to visualize a 3D object's UV coordinates or mapping coordinates. So what it is checker, red and green, with a couple little markers on it. It's easy enough. We're going to click the Show Map in Viewport button here so we can take a look at this, and we'll see with this we can easily visualize what this object's UV coordinates are. Now in 3D Studio you actually have three mapping coordinates. You have U, and you have V, and you have W, and those are simply the letters of the alphabet that come before X, Y, Z. So we talked about X, Y, and Z coordinates. Those are coordinates in 3D space. But when we're discussing coordinates in 2D space, or space designed to be mapped onto an object, we say U, V, and W. Now most textures are 2D, and so we only use the U and the V. However, if we use a 3D texture, or if we manipulate a standard 2D texture in certain ways, we can use the W coordinate. So this is a 3D object here, but we need to put a 2D texture map on it. So we need to have some way to specify, well, where does this part of the 2D picture, 2D texture map, go onto the 3D object. And so it uses these coordinates U and V, and U and V simply go from 0, this would be 0, all the way to a 1 coordinate in U, and a 1 coordinate in V, and a 1 coordinate in both. So the UV coordinates, U and V, of this point here would be 0, 0. The U and V coordinates of this point here would be 1 in U and 0 in V, because I haven't gone anywhere in V. Again, here would be 0, comma, in U, 0, comma, 1 in V, and then up here would be 1 in both. And so right in the middle would be 0.5, 0.5. And we can take that plane here, and if we go, and we're going to make it a few more segments, and then if we do add a modifier to it, like a wave or something like that. So if we make this plane wavy, right, our texture is still being drawn on it in the same manner. Any sort of deformations that we do to this thing, the UV coordinates remain unchanged. So even though this plane has gotten a whole lot more 3D, the UV coordinates are still cemented onto each point of geometry. You can also think of this pretty easily if you have something like, well, if we make a sphere, have that, and then we get the material editor here. We're going to assign this new material to that sphere. I'll map this with a thing, and then choose all formats, and somewhere in here we have an earth. And if I choose the show display in viewport, we have our little earth here. So there is a bitmap. Okay, so this is an image of that map, and that map is essentially to be applied to a 3D object. We have to unwrap it. And so you can think of coordinate systems here too. We have a coordinate system for the Earth, kind of like UV, but it's latitude and longitude. So you could pick any particular point in latitude and longitude on, let's pick Denver, Colorado, that's my hometown. So you pick any coordinate on this 2D representation of the picture, whatever is the surface of that object, this 2D representation here, it also has a corresponding coordinate on the 3D object. So u and v is a little bit like latitude and longitude, if you want to think of it that way. There's all kinds of different ways to so-called project UV coordinates onto an object. You can do it in a planar way. So if that thing is a plane, you can do it spherically, you can do it cylindrically, you can do it all these different ways. Now, most primitives in 3D Studio, box, sphere, whatever, plane, when you create them, has a little checkbox down here, generate mapping coordinates. And what that will do, well, it will create these mapping coordinates or these UVs for you, and so you don't have to, if you're working with just primitives, you don't have to worry about what your UVs look like until you start texture mapping it. Maybe you can alter them a little bit, change them up, whatever you want to do to them. You can modify them at any time, and you can do all kinds of neat things with them. But for the most part, if you're using primitives, you don't even have to ever worry about it, because 3D Studio will generate some UV coordinates that make sense for whatever kind of object it is. So if it's a plane or if it's a sphere, that's very simple. But if you do certain modeling operations, will destroy UVs or kind of muck them up, it will muck up these mapping coordinates. Even if if I take this sphere and I were to go in and modify it a little bit, if I come in here and do an edit poly operation on this sphere and pick a couple of faces there, let's pick a couple of faces, and then I do something to it, like extrude those faces. Now all of a sudden my mapping coordinates are going to be a little bit messed up. See, it preserves the mapping coordinates here, but it doesn't really know what to do with these new faces that are generated. So if you make modifications to some geometry, you can end up with some kind of screwball mapping coordinates, and that's when you have to go in and edit them by hand. So on our object here, which was largely made from primitives, let's get rid of these two little guys here. So this thing was largely made from primitives, and so we might be able to get away with not worrying about our mapping coordinates for a large part of this thing. However, certain parts of it, like the walls here, I made from several planes all in a row. We did do something with the wheels, like we made these from a couple of segments of pieces of pie. This frame we took and extruded and beveled and chamfered all kinds of pieces out of it, and so mapping coordinates are going to be a little bit goofy. Things like this is just a box, so that one's going to work out great. That's just a box. These are just hemispheres. So some stuff you have to worry about and some stuff you don't. What we're going to do is texture map this thing, and we're going to, you can do it a couple of different ways. You can make sure that your UVs are all correct first, or you can start putting materials on the thing and see what you need to fix and see what you can get away with. So if you were modeling something to hand off to somebody, you would want to go in and double check, make sure that your UVs are all correct for the entire object before you handed it off to somebody else who is painting the textures for it. But in the case of this object, we're just making it for ourselves, and so we can kind of fix the UVs as we go and put textures on. Now, if you were trying to test the UVs or the mapping coordinates for this object, you could create we already created a material here that had that bitmap on there, just a UV utility map. You can take that and put it on here and make sure that it's shown in the viewport, and then you can take a look at what the mapping coordinates of this look like. Well, you can sort of see that this was made out of a series of planes, so it's all repeated across there. You see, you have one repetition of every map, or of the map along every plane there. So these UVs probably aren't going to work out for that. I want to have this surface act as one big piece. And if we look down here, let's see what else. Well, these UVs look pretty good because that was just made out of a chamfer cube. These UVs are okay too. UVs along on this little pull there that seem like they might be okay too. We'll have to look at it a little closely. The chain links are going to be okay. Those are just toruses. This little thing, that might be okay. Depends on how we, what the texture is we want to put on there. But anyway, good form for UVs is to sort of make sure that you've got, that looks pretty good too, is to make sure that they're even and they're spaced out nice and even. You don't have any real skewy parts. The skewiest parts we're going to have are kind of down here on the frame, because that's the thing where we did a series of bevels and chamfers and things. So some of them, see, they get kind of out of whack here. They get skewed. You want to avoid skewing when you're looking at these little checkerboards. That's the main thing to kind of double check. And here we have on the wheel, we have some real crazy UV errors. This one seems okay, but all the rest of these are real goofed out. So that is something you really want to avoid. If your UV utility maps on there like that, that's not going to work at all. So for the most part, this thing looks pretty good. We're going to make a few simple modifications to it.